We are going to go through Kamssa mock item number 1. And this item, this is a screenshot of how that item looked like. And this is the item. Now, whenever you meet these scenarios, read through the scenario and summarize your work. After summarizing, look at the task at hand and then you start responding basing from the task you have. They told us that we have two people, we have Cargo and we have Beatrice, who own a company or who came together and started a company. And each of them contributed a certain amount of money. So we are going to start summarizing our data that we do have. Now, we have two people who came together and contributed. So we are going to say contribution to the company. Now, the contribution to the company, we have people. And what did they contribute? They contributed the capital to run the company. So I'm going to have here a simple table. And now this simple table I have, these people contributed capital to run the company. So we have two people. We have Cargo, and then we have Beatrice here. So this one contributed this amount, and this one contributed 120,000. So this is the amount that each of them was able to contribute. Then when you go on, they told us that the second paragraph here, one day Cargo received a bunch of 460 liters of chemical A. Take an example. This is my bunch and this is my chemical A. And this one has 460 liters, which was 75% pure. So it is 75% pure. He decided to mix it with another chemical of the same type, but with 90% pure. So now we have a second chemical. This is, I'm going to call it chemical 2. However, we are not sure of how many liters were for this chemical, but its purity is 90% pure. Then, but with 90% purity to a final mixture that is 70. Now we are going to have a final mixture. So the final mixture we are going to have has two things. Has chemical A, but also has the second chemical, let me call it 2. But when we mix chemical A and chemical B, we get 78% of purity. Now, when you look at the first task in the question, they are asking us that what is the amount of chemical 2 that was being put or that was put such that our chemical purity becomes 78%. So they're asking us that what is the amount of the 90% pure chemical that Cargo must add to the 460 liters such that we obtain the 78%. Now that is the first task. So in order for us to do that task, we must use the knowledge from this second paragraph to be able to do it. And how are we going to do it? In order for us to get the chemical, we need to know that we have to mix the mixture. I'm going to call it the mixture of chemical A, plus the mixture of chemical B, which I'm calling B, should give us our final mixture. Now that is now the simple equation we do have. That when I get the number of liters of the first chemical plus the number of liters of the second chemical, I must be able to get the final mixture. So I'm going to say that let y be the number of liters, be the number of liters contributed by the 90% purity mixture, purity mixture to the final mixture. So how are we going to get? It means that when I get the number of liters, now I'm going to say the number of liters of A plus the number of liters of B must be able to give me the final mixture. That is what now you need to know. That the number of liters contributed by A plus the number of liters contributed by the second mixture should be able to give you the number of liters for the final mixture. So how do we get the number of liters that is contributed by chemical A? Chemical A, remember, it was 75% pure. So if which was 75% pure. However, what was its contribution to the 460? So what we shall do, here we are going to come and say 75% times the 460. This is the kind of purity that the first mixture of A contributed. Then plus the mixture of B. Since it was 90, we shall say 90 out of 100 times its contribution. This is the percentage it contributed. Then what about the final mixture? The final mixture is going to be, since it is 78, it will be 78 out of 100. Then what is the final mixture when you combine A and B? When we combine A and B, the total number will be 460 plus Y. Now, this is the kind of equation that we have formed. So we are going to work out this kind of equation. So we are going to do the mathematics. For the first one, we shall get 345. That is the amount of chemical of A that was being contributed to. Plus, the second one here, you are going to allow me to write it as 0.9y is equal to 0.78 into 460 plus y. So the 345 is the amount of the 75% that was contributed to the final mixture. So this will give us 345 plus the 0.9y. When we open up our brackets, we shall have 0.78 times the 460 plus 0.78 times y. So this will give us 345 plus 0.9y, which will give us 358.8 plus 0.78y. So we collect like terms. So when I'm collecting like terms, I'm going to say 0.9y minus 0.78y will equal to 358.8 minus the 345. So when you subtract, this will give us 0.12y equaling to 13.8. So divide by 0.12, divide by 0.12. So your y will equal to 115. So, and these are the liters that must be contributed by the 90% purity to form the final mixture of 78%. So I'm now going to conclude my question, and I say, therefore, the amount of the 90% pure chemical that cargo must add to the 460 liters to obtain 78% pure mixture is 115 liters of chemical of the second chemical. So that's how I can conclude that. Alternatively, another person could as well do this number using another approach. Take an example. We know very well that to get the percentage, you know that when you get the total pure chemical, divide by the total volume, should be able to give you the 0.78. Another person could have attempted it in that up way. So you still get the same answer. Then the second part B, wanted us to find a fraction of the work that was left after machine A. Still, the first thing always you do, you first go on and summarize your question. Now, when you look at our question, here they told us that to be able to mix the packets, we had 3 machines. So I'm going to come here and say the machines. So we had machine A, we had the second machine B, and then we had the third machine C. Then were used for full production. Now, here we have what called a production cycle. Machine A can complete a full production in 6 hours. This one, here I'm going to say the time in hours. The first machine can take 6 hours. The second machine B takes 8, and this one takes 12 hours. Then they went on and told you that all the machines were started at the same time. However, after 40 minutes, machine A broke down. Now, what are you going to need to do? One, you need to find out at what rate does each of these machines work at. That's what we call the rate of the work rate. What is the work rate? Work rate means the fraction of the job that can be completed per unit time. That's what we call the work rate. So you need to find out what is the work rate for each of the machines. Now, we are going to find out that work rate. So the work rate, I repeat, work rate means the job that can be completed by the machine per hour or per unit time. So I can say let the work rate be represented by R. I'm using R. So when it comes to A, it takes 6 hours to complete. So that means that if you, per hour, how much work can it do? That is what we call the work rate per hour. So I can say work rate for machine A. So the work rate for machine A is going to be 1 out of 6. What about for machine B? It's going to be 1 out of 8. What about for machine C? It will be 1 out of 12. That is what we call. That means that per hour, it completes an amount of work of 1 out of 6. For B, it completes 1 out of 8. For C, it completes 1 out of 12. Now, you are going to ask yourself, now, so that is the first thing you need to find out. Then you are going to ask yourself, what is this? You are going to ask yourself, what is the total work that is going to be done by all the machines? Or what is the rate at which if all the machines are to function normally, how much work will they be able to do and how much time will they take? So we are going to find what we call the work rate or the rate of doing the work. When you combine, what is the combined work rate? So if these machines are to work together, that means we are going to say combined work rate. If they are to work together, it means we shall have 1 out of 6 plus 1 out of 8 plus 1 out of 12. So when you do the mathematics, this will give you 3 out of 8 per hour. So this is the amount of work these machines can do per hour if all of them are working at the same time. Now, our question wanted to find out, find the fraction of the work that was still left after machine A broke down. Now you are going to ask yourself that. This is the amount of, you are going to ask yourself that if machine A breaks down, how much work was done by that time? So you are going to first find the time. This is work rate, so I'm going to find the time. So the time they told us that machine A broke down after 40 minutes. So I'm going to come here and I say time is good time when machine A broke down. So it is 40 minutes. Since we are working in hours, we shall say 40 out of 60, which will be 2 out of 3 hours. Now, this is the time. Now, you are going to ask yourself, how much work had they done by that time? So, when we are talking about work rate, we have said our work rate is 3 out of 8 per hour when all the 3 machines are working. That is the kind of work they can do. Now, we are going to find that is the work rate. So, what about the work? So, work is given by the work rate, the rate that you are working on, then times the time. So here we shall say the work rate is going to be the 3 out of 8 times 2 out of 3. Now this one will reduce, when you try to reduce, this will be 1 out of 4. That means that the amount of work they had done after the 40 minutes was just a quarter of the total amount they had to do. If you are to relate this, you can relate it to the concept of power. Power is the rate of doing work. So if I relate it a bit from that angle, you know that power is given by work done out of time. So if you want to find work, work is given by the power times the time. So power here is your work rate, then times the time. So to get the amount of work you have done, you get the power times the time. So power for this case is the work rate, then times the time. The time the amount of work you can do per hour is what we call the work rate, or how much work you can complete per hour. So that's how you find out the work. That means that the work they had done was just a quarter. So, however, they're asking, find the fraction of the work that was still left after the machine broke down. So to find the work left, I'm going to come here and I say, work left after the machine, after the machine had machine broke. So we shall say that the total amount of work that should be done is 1 minus a quarter. So this is the same as having 1 out of 1 minus 1 out of 4, which will be 4 minus 1 out of 4, which is equal to 3 out of 4. That means that our fraction, when I'm responding back, I'm going to say that the fraction of the work that was left after machine A block was 3 quarters. So that means that this is what they were remaining with to finish the whole process. So that is the first part. Then the second part, they asked us that, hence, determine the fraction of the work done by machine C working alone for 20 minutes. That is the second part. They're asking us to find the work done by machine C working alone for 20 minutes. Now you're going to ask yourself, if this machine is working alone for 20 minutes, how much work? So you are going to first find. So I'm going to go and find out machine C working alone for 20 minutes. So I'm going to come and say, I'm going to first find the time. So the time is going to be, since they told you working time for the 20 minutes. So our time here is going to be 20 divided by 60. And this one will give us 1 out of 3 hours. But since it is machine C working alone. Now, we know very well that at what rate does machine C work on? Machine C works at a rate of 1 out of 12. So to find the amount of work, like we have said, work would be the work rate, then times the time. So the work rate the machine is working on, machine C, works at a rate of 1 out of 12. That is the amount of work it can do. Then times the time it used, which is 1 out of 3. So times the 20 minutes, which is 1 out of 3. So this will give us 1 out of 36. That means that the amount of work that can be done by machine C working alone for 20 minutes is 1 out of 36. So that is the fraction. Okay. Then so that is how you can attempt it. However, the other, so that's how you can attempt it for that particular part. Okay, I can now continue. So that's how you had to do that second part to find a fraction working alone. Then part C, wanted us to determine how much each partner received at the end of the first year. When you look at our scenario, you are going to come back in paragraph 3. They asked you that at the end of the year, the company made a gross profit of this. They agreed to reinvest 25% of this profit back into the business, and 40% was used for salaries and other annual expenses. The remaining profit was shared between them. Then they're asking how much each person received at the end of the first year. So I'm going to come and I make my calculations. The first thing I'm going to calculate, I'm going to find out how much profit was reinvested. So I will say, this is now on part C. I will say profit reinvested. So the profit reinvested into the business was 25%. So I will say 25 out of 100 times the amount, which was 181,300. So this will give us shillings 45325. Then I'm going to say amount spent on salaries and annual expenses. So they told us that was taking 40%. So I will say 40 out of 100 times the 1,813. Since this amount was obtained from the profits they obtained, so this would be shillings 72520. Then I'm going to go back again, still from my question. But I want you always to be very observant. When they use UGX, please also stick to UGX. Do not change the signs. So for this particular one, here they were using UGX. They were using UGX. So that is those are the units you stick on. So I'm going to come here and I write here that this is UGX and this is UGX. Then now you're going to ask yourself, the profit that remains is what they are going to share. So I'm going to ask myself, remaining profits. Remaining profit. So to obtain the remaining profit, what are you going to do? You are going to get the total profit, or what you can call it the annual profit minus the expenses. So here the total profit was 181,300 minus what they had spent, which is 452,325 plus the 72520. So when you do, this will be 181,300 minus this is 117,845, and this will give us UGX 63455. Now, this is the amount of money they are remaining with. So that means that if they are to share, they must be able to share the 63,455. Now, how are they going to share? Initially, they told us that their contribution, cargo contributed 90,000. Then the girl, Beatrice went on and contributed 120,000. So they have to share this money amongst themselves. So you have two things you can do. You can first reduce this into simple fractions if you want. So I can say their ratio, I can decide to divide this by first 10,000. I divide here by 10,000. So this will be 9, and here I'll have 12. Still, I can go on and divide. I divide this by 3. I divide this by 3. So it becomes a ratio of 3 to 4. Now, that is the one option you can do. Then from here, you say that my total ratio is equal to 3 plus 4, which will give me 20. 3 plus 4, which is going to give us 7. 3 plus 4, that is 7. So, a minute. Okay, this is 7. Then I'm going to find cargo's share. So I'm going to say cargo's share. So cargo's share is going to be his contribution, which was 3 parts, out of the 7 times the profit they obtain that was remaining. And this will give us UGX 27195. Then I go to the Beatrice's share. When it came to Beatrice, Beatrice contributed 4 out of 7 times 63455. And this one will be UGX 36260. That is how much money each of them got at the end of the first year. So now that is the part you are working on. So that is the first part. Now, what are you going to do? You are going to conclude that at the end of the first year, Beatrice obtained this amount of money, and the other person, Beatrice obtained this amount of money, and the other person also obtained that amount of money. Then the second part told us that, and the total amount each pattern after dissolving. Now, after that, you notice that this third paragraph, they dissolved the business. So now you are going to calculate how much money did each of them obtain. But remember, the money that was reinvested back in the business, it was used as capital, as operational capital. So now this last part has quite a lot to do with it. So I'm going to ask you to try it out and then obtain how much each of the pattern obtain after the second year. So that is how you can attempt this particular item when it comes to that particular part. Then as well, maybe to throw more light, they can as well have asked you how much work was done by B and C and the rest of that. Yeah. So